Hello everyone. Today I would like to give you a lesson on the topic parallelogram.
Before starting to watch this video, don't forget to subscribe to my channel and like it. I will be very grateful to you for that.
Some architectural buildings around the world, including those in the United States and Europe, have a plan or shape that is close to a parallelogram. Here are some examples. The Shard, London, United Kingdom. Although it is a skyscraper, its base and some of its facade faces can be seen as parallelogram shapes. Flatiron Building, New York, United States. Although the building's facade is triangular, part of the building's plan and side facades form parallelograms. So what do we call a parallelogram? A parallelogram is a quadrilateral in which every two opposite sides are parallel.
Here are these interesting examples in front of you.
Let's carefully look at the properties of a parallelogram. 1. The opposite sides of a parallelogram that lie opposite each other are of equal length. AB equals CD, BC equals AD. 2. The opposite angles of a parallelogram are also of equal length. Angle A equals angle C, angle B equals angle D. 3. The sum of any two angles adjacent to the same side, adjacent angles, is 180 degrees. Angle A plus angle B equals 180 degrees, and angle C plus angle D equals 180 degrees. 4. The diagonals of a parallelogram intersect, and the point of their intersection bisects each diagonal. AO equals OC, BO equals OD. 5. The sum of the squares of the lengths of the diagonals of a parallelogram is equal to the sum of the squares of the lengths of all four of its sides. Let's look at the basic formulas for calculating the area of a parallelogram. The area of a parallelogram can be calculated using two basic formulas. S equals A times H, the product of the base times the height drawn to the space, or
S equals A times B times sine of beta,
the product of two sides times the sine of the angle between them. First of all, let's prove how we can find the area of a parallelogram by multiplying the side by the height drawn to the side. And so we have a rectangle ABCD. I denote that in it that AB is equal to H and AD is equal to A. Well, let's remember how we can find the area of a rectangle. S equals A times H. Let's draw a segment AF, and here's what we'll do. We'll move the triangle AFB relative to the side CD so that we have a parallelogram formed, and here we have a parallelogram AFBD. I would like to move this height here so that we can see it better, and I'll denote accordingly that this is our height Fn, and the formula is obvious. A times H is the same as for the rectangle, because our area has not changed. We just took the rectangle and kind of bent it to the right. That's all. Now let's prove how we can calculate the area of a parallelogram as the product of two adjacent sides times the sine of the angle between them. Well, we have the base of the parallelogram. Let Fn equals H, AD equals A, FF equals B. H is perpendicular to A, and we are asked to prove this formula. Well, let's take the triangle AFN, and in it we find the sine of beta. Sine of beta is equal to the ratio of H to B, hence the height is equal to the product of B times the sine of beta. Now, in the last slide, we proved that the area of a parallelogram can be calculated by the formula A times H. Now, instead of the height, we substitute what we just found, and we get another formula for finding the area of a parallelogram. Problem 1. Determine the areas of parallelograms using the given data. So we see before us a parallelogram in which the height and side are given. Here I have highlighted them in blue and green. Now, the formula for finding the area of a parallelogram in this case can be used such that the area is equal to the product of the side by the height drawn to it. So we know that the opposite sides of the parallelogram are equal and parallel. Here I highlight the opposite side to this side, which is highlighted in green, and I get that the opposite side will also be equal to 15. So in the formula, we substitute S equals 15 times 18, and the final answer is 270. We see a second parallelogram in front of us. We are asked to determine its area. So we know that the opposite angles of a parallelogram are equal. So this angle, the rays of which are highlighted in green and blue, will also be equal to 45 degrees. So we write the second formula for calculating the area of a parallelogram. S equals A times B times sine of alpha. And we have that S equals 6 root 2 times 12 times sine of 45 degrees. So the sine of 45 degrees will be equal to root 2 divided by 2. So after we calculate this, we will have the answer 72. Problem 2. In the parallelogram ABCD, point P is the midpoint of side AD. Triangle ABP is an equilateral triangle with the perimeter of 42. Determine the degree measure of angle BCD. Here I have already drawn a parallelogram in which I marked equal sides AB equals BP equals AP equals PD. So if this triangle ABP is equilateral, then the angles in it will be equal. They will be 60 degrees each. So now we have to remember that the opposite angles of a parallelogram will always be equal. So if angle A is 60 degrees, then the opposite angle C will also be 60 degrees. We were asked to find the degree measure of angle BCD. So we have already found it. The answer is 60 degrees. Let's move on to solving another problem, the condition of which will be the same as in the previous problem, but here we are asked to determine the perimeter of the parallelogram ABCD. So according to the condition of the problem, the perimeter of the quadrilateral ABP is equal to 42. Therefore, if we add the sides of this quadrilateral, we will have 3a, and 3a will equal 42, because as you remember, the perimeter is the sum of all the sides. And from this equation we have that a is equal to 14. Therefore, if we have side AB equal to PD, then I also have to denote this side by A. And since AB is equal to PD, then side BC will be equal to A plus A equals 2A. And since AB is equal to CD, then CD will also be equal to A. Hence we have that the perimeter of the parallelogram ABCD is equal to A plus 2A plus A plus 2A is equal to 6A. And now we have to substitute 14 for A. So 6 times 14 is equal to 84. So that's going to be our answer. Let's look at the last problem for today, the condition of which is already familiar to you now. We are asked to determine the area of the parallelogram ABCD. So from the previous points, we know that angle C is 60 degrees. If CD is 14, then BC is twice as large as 28. Now we must recall the formula for finding the area of a parallelogram. We will use the formula for finding the area of two sides and the sine between them. So we have that the area is BC times CD times sine of 60 degrees. From here, we substitute the known quantities, and we have that the area is 28 times 14 times root 3 divided by 2. And from here, we have that the area is 196 root 3. Therefore, this will be our answer. So if you understood everything today, I would give you Brought Superior Austin Martin AMB 001 as a gift. If you are worried or excited because you did not understand something, no problem. Watch this video again slowly. Never give up. And I wish you to understand it as soon as possible. Bye.